Hello everyone, welcome to the channel. Today we are going to solve physics paper 2 multiple choice paper, which is extended edition. It's May June 2025. So let's begin with question number 1. The speed time graph for a racing car is divided into four sections: P, Q, R and S. The car starts the race but soon crashes into a wall of tires. Which section of the graph shows that there is an acceleration that is changing? So as you can see, we have speed time graph. On y-axis we have speed, x-axis we have time. In section P and section S we don't have a gradient, so it means that there is no acceleration. While in section Q we have positive gradient, section R we have negative gradient. It means that in this section the car is accelerating and here the car is decelerating. So these are two sections in which acceleration is changing. So option C is the correct answer. Question number 2. The diagram shows the four forces acting on an aircraft in flight. Which arrow shows the direction of the resultant of the four forces? So as you can see here, 60 Newton is a forward force, 40 kilonewton is a backward force. So it means this 40 kilonewton cancel out this 60. So here we have 20 kilonewton forward force. Here 120 kilonewton upward and 60 kilonewton is downward. So this 60 cancel out this 120. So we have 60 kilonewton upward force. To find the direction of the resultant, we will draw the vector diagram. 60 kilonewton, 20 kilonewton. It means the resultant vector would be here. So as you can see, A and B both are having same direction. C and D is wrong. So to find the exact answer, we will find the angle. So we get angle by using theta equal tan inverse Fy over Fx. Now we will put the values. Tan inverse Fy is 60 kilonewton over 20 kilonewton. So the answer is 71.5 degree. It means that A is not a correct answer, B is the correct. So option B is correct answer. And keep in mind, while you will calculate the angle, your calculator must be in degree. Some students, while they are calculating, they are not checking the mode of the calculator. It should be in degree, then you will get the correct answer. Question number 3 is, the diagram shows two metal blocks X and Y suspended from identical force meter. X and Y have identical dimensions. Identical dimensions means they have same length, width and height. So if they have identical dimension, it means that they have same volume. Okay, which statement about X and Y is correct? So as you can see, on X we have 2 Newton weight and object Y have 3 Newton weight. They have different weight but have same volume. So option D is the correct answer. They have equal volume and different weights. Question number 4 is, a girl has a gold necklace. Which apparatus does she need to find the density of the gold? To find the density, we are using a formula, mass over volume. If we need to find the mass of any object, we use balance. And to find the volume of object, we will see, yeah, this is a necklace, so it means that this object is irregular. So to find the volume of irregular object, we will use measuring cylinder. So it means C is the correct answer. Question number 5. A spring has a length of 25 centimeters. So this is original length of the spring, 25. When a load of 2 Newton is suspended from it, the spring has a length of 35 centimeter when a 7 Newton load is used. What is the spring constant of the spring? So we have to find spring constant. So this question is actually from Hooke's law. F equal kx. Hooke's law states that extension is directly proportional to the applied force within the limit of proportionality. So here we have to find spring constant, k equal F over x. You can see we have two forces. Initially we have 2 Newton force, then we have 7 Newton force. So it means that 7 minus 2 equal 5 Newton is the resultant force. Initial length of the spring is 25 and final length is 35. So 35 minus 25 equal 10 centimeter. This is extension. So 5 over 10 means 0.5 Newton per centimeter. This is spring constant. Question number 6. The diagram E to H shows a block of wood on a frictionless surface. In each diagram, the block has two forces acting on it. Which diagram shows the block in equilibrium? So you have to keep in mind for any object, if we need to keep in equilibrium, there are two conditions. Number one, sum of forces must be equal, or no resultant force acting on an object. And number two, total moment total moment or no net moment should be there. Total moment must be 0, right? So look at this. Here we have 2 Newton force, and here also we have 2 Newton force. These both forces are having equal magnitude, but their point of action is not same. They are, it means that this object will not have an equilibrium condition. Okay, here we have 2 Newton to the left, 2 Newton to the left, so it means that resultant force is 4 Newton. So this is also wrong. Here we have 2 Newton to the left and 2 Newton to the right. It means here we have 0 Newton resultant force. This could be correct. And this also 2 Newton to the right, 2 Newton to the left. So we have 0 Newton. So G and H only. Option D is the correct answer. Question number 7. Which statement is not correct? The momentum of a system is conserved in all interactions. So if the system is isolated, we can say that total momentum before collision is equal to total momentum after collision. Total momentum before collision equal total momentum after collision. So statement A is correct. Impulse equal change of momentum. Yes, this is also correct, because if we derive the equation for impulse by using Newton's second law of motion, F equal ma, and F equal mass into final velocity minus initial velocity divided by time. So it means here we get the equation mv minus mu divided by time. So force multiplied time equal mv minus mu. This is called impulse, and this is called change in momentum. So option B is correct. Force acting equal change of momentum multiply time. Yeah, this one is wrong, because here in third step you can see force equal change in momentum divided by time, but here we have multiply. So option C is correct. Question number 8. The force acting on a moving ball causes its motion to change. This force stays constant. What makes the force produce a greater change in motion of the ball? So if we look at Newton's second law of motion, F equal mass time acceleration, and acceleration equal force over mass. Here we have constant force, so it means that acceleration is inversely proportional to mass. It means that bigger the mass of the object is having, less acceleration, and less mass would have more acceleration. So decreasing the total mass of the ball would have greater change in motion. So option A is the correct. Question number 9. A farmer has two carts. The cart have the same weight, but one has four narrow wheels and other has four wide wheels. Which cart will sink less into soft ground, and what is the reason? Okay. So here this question is related from pressure. Pressure equal force over area. They said they both have same weight. It means that they are having same force. So pressure is inversely proportional to area. Less area would create more pressure and it will sink into the ground, while if we have more surface area, so it means it will create less pressure and it will sink less. So you can see here wide wheel is having more surface area while this wheel is having less surface area. So cart wheel would be wide and less pressure on the ground. Option D is the correct answer. Question number 10. A hot gas and a cool liquid are at the same pressure. They have same pressure. So which law describes the separation and the motion of particles of hot gas compared to the cool liquid? So let's suppose we have two containers. In one container we have hot gas. Here we have hot gas, and in other container we have cool liquid. So as you know that by increasing the temperature, the kinetic energy of the molecules will increase, and due to that their motion will increase, and if they vibrate with faster rate, so what will happen, their separation would be more, separation more, so greater than a cool liquid. Separation of gas particles greater than cool liquid, yes, this is correct. Motion of gas particles faster than cool liquid. Yes, because in cold water the particles will have less kinetic energy, so it means option A is the correct.